Today we're going to be learning about graphs of linear equations and functions. Now this is worth 44 points on the math section of the SAT, so one of the largest concept types. Definitely understand these. So let's look at our approach. First, we're going to identify graphs of linear equations and functions questions. We're going to analyze the question. We're going to build a formula to solve them, and then we're going to go through a practice question together. So how do you identify these questions? Well, first, they'll generally show up as a graph on the XY axis, or they might just mention the XY axis. And what I mean by mention is that they'll say something like, the equation blank graphed in the XY axis does this. What is blank? And so they'll mention their function or equation being graphed in the XY axis, and that's another hint you're dealing with this concept. They'll show up as a line in the graph, and here's some common things they'll ask you about. Sometimes they'll ask you the slope. Sometimes they'll ask you the x-axis. Sometimes they'll ask you the y-axis. And one of the most common ones I see is about translations. Now, translations is an important one to remember on the SAT because these questions are common. So let's do a quick reminder of what translations are. So let's say we have our equation f of x. So if we take f of x and we add 3, this is moving our equation up 3 units. And so your y-axis is going to move up 3 units. So up 3. Okay, and then the opposite of that is if we had f of x minus 3, we're moving down 3 units, and this will make your y-axis 3 units less. Now, we also have f of x plus 3 inside of the parentheses here. And if it's inside, then we're shifting left to right, and plus is going to shift us left. Left 3, and so this will actually change our x-axis to be left 3 of where it was. And then lastly, f of x minus 3 is going to shift us right 3. And so your x-axis will be 3 units to the right of where normal f of x was. So just remember these translations. You can also plug in test values if you can't remember if it's up, down, left, right, and that'll help you figure it out. But I would remember these as well. So let's look at our formula of how to solve these questions. Step number 1, we're going to analyze the graph. Step number 2, we're going to write down what the question is looking for. And lastly, we're going to apply what the question is asking to the graph, and then we're going to find our answer. So let's look at this practice problem. It says the graph of linear function y equals g of x plus 15 is shown. If a and b are positive constants, which equation could define g? Well, I'm looking over here at this graph, and it's telling me that this graph is of the linear equation y equals g of x plus 15. Okay, so I'm just writing that above my graph so I can kind of keep track of this graph is showing me g of x plus 15. And just looking at the graph, I'm seeing it's trending downwards. So as our x values increase, our y values decrease. So this is telling me negative slope. And I'm seeing our y-axis here of 0, 4. And so this is just my quick analyzing of the graph. But let's move on to step 2 and see what this question is looking for. So we're looking for which equation could define g. Now, if you were working quickly, you easily could have looked at this graph, thought it was g, and got this answer wrong. And this is something they often do. So that's why I like labeling up here, y equals g of x plus 15. So now that we're just looking for g, let's pay attention to our translation rules that we just learned. So we'll write down our equation again over here. Y equals g of x plus 15. And so if we're looking for just g, we're going to want to subtract this 15 out, which will give us g of x. But we have to think about what's actually happening when we subtract this 15 out. So if we remember a plus 15, this right here is going up 15 units for our y-axis. So right now our y-axis is 0, 4. And if we get rid of the going up 15, that means we'll go down 15, right? And so that means our new point here is going to be 0, negative 11. So this is our old y-axis, and this is our new y-axis, right? So we see that our y-axis goes from positive to negative now. And in the last step, we agreed slope equals negative. And we know this because as our x's are increasing, our y's are decreasing, and vice versa. And so putting these pieces of information together, while also knowing a and b are constants, I'm looking for an equation of g of x that has this negative slope and has a negative y-axis, because we know that our new y-axis is negative. So for me, I'm seeing a negative slope on a negative y-axis on a, and the term next to the slope is negative too. And so I think a is a good choice for me. We can look at these other ones. This one's got a positive y-axis, so I'm saying no. C has a positive slope, I'm saying no. And D has a positive y-axis and a positive slope, so I'm saying no there. So I think A is going to be my answer. As you can see, A is correct. And so this is how you kind of tackle one of these problems from start to finish. In terms of Desmos shortcuts, since these questions give you a graph already, you can't really plug it into Desmos since you already have your graph. But like I mentioned, some of them will just mention the XY axis. So if they just mention this XY axis, you can take the equation that they're trying to get you to put in the XY axis and plot it, which will help a lot. So definitely plot it if you're not given the graph already. And another really helpful thing you can do is if you go in Desmos and you make an equation f of x equals x plus 5, you can actually do these translations in Desmos and see how they work. And so let's do this together. Okay, so we're in Desmos now, and I'm going to type in f and then a parenthesis sign, and we're going to put x in there equals x plus 5. So we see our graph right here. Perfect. Now the cool thing is I can put f of x and I can do minus 5. And it'll take my f of x equation here in red and it'll do minus 5. And as you can see, it translates it down 5 units, which is what we would have expected. So if you're working with translations and want to check your work, definitely use Desmos. It's worth your time. And if it's not a translation one, try plugging in a Desmos and see if it helps you. So good luck on this concept.